Hello, my beautiful computer science students. Welcome to Lesson 6 on for loops in our Unit 2 on selection and iteration in AP Computer Science A. Today we're going to be introducing the for loop and how we use it in Java and just really the basic syntax of it. In later lessons, we're going to get into actually the algorithms that are going to be using the for loop. So I'm excited for you to learn about this new loop. We've learned all about while loops up until this point, so this is going to be the new loop that we are going to encounter. So if you're new here, I am Goldie and I'm going to take you through this entire lesson today. So go ahead and grab your notes, get settled in, and let's learn this material together. So the for loop is a loop that we are going to use in addition to the while loop, okay? Now the while loop works really well when we don't know how many times a loop needs to run. And the for loop kind of fills the gap of, okay, I know how many times maybe I need to run. Let's use a different loop with a different header, a different structure that lets us kind of communicate that more clearly. So you'll use both of these loops throughout the course, and we'll talk about certain situations where the while loop works better, and then there's certain situations where the for loop will work better. And then, of course, there are certain situations where you could really use either. It's just a matter of preference. All right. So what is the for loop? So the for loop header is actually going to do a lot more work for us than the while loop. The while loop header just was a condition, but the for loop header actually has three parts to it. The initialization is going to come first. So if you look over here at the syntax part over here, we have our for and then parentheses. And then inside parentheses, well, with a while loop, it was just a condition. But inside with the for loop, we're actually going to have three parts that are going to be separated by a semicolon there. Okay, so the three parts. The first part is the initialization, which sets a variable equal to some value. Now, this initialization part only runs once. As soon as the loop is reached in the code, the initialization only runs once. After the initialization, then we move on to condition, which is going to be the middle part of the for loop. Now, the condition uses the variable that was initialized and checks it against some condition. And if that condition is true, then the for loop is entered. If the condition is false, the for loop ends right away and it's never entered, okay? Or if at any point the condition, when you go back to check it, if it does become false, then the loop also ends, okay? So that condition needs to be true in order for the for loop to be entered. After all of the statements inside the for loop have run, the loop loops back up to the third piece of the header, which is the update piece. Now, this update piece will update the variable that you used in the initialization. It'll update it in some way. It might add values to it, subtract values to it. It'll do different things to the variables, usually add or subtract values to it, but it could do other things. But it'll update that variable in a way that changes it, and then the condition is checked again to see, okay, we updated that variable. Let's go back to the condition and check to see if it is still true. Okay. So what you see on the screen here is kind of the flow of control that we have for this for loop. The initialization happens once, and then we get, here's our loop. Okay, we have the condition, we check, we run the statements, we update the variable, and then we check to see if the condition is still true. If the condition is true, we go through the statements again, we go through the update again, check the condition again. And we get in this loop until the condition is false when we go to check it. Okay, we have to check it first in this order of execution here. And then when we go to check it, if it's false, that's when we end our for loop. So let's see just some basic examples here to get an idea of how it works. We're going to trace through this. So what you're looking at now is a simple for loop that has the three parts. You can see that the variable we are using here is I. And that's most often the variable you're going to be seeing used. Okay, it's usually a single letter in a for loop. It can be something like val, num, count. I mean, you can name variables anything, but usually it's a single letter just because we use that single letter quite a few times. You see I is initialized to 1 here. Then you see I is used in the condition here. And then you see I is used in the update here. So I is used 3 times in the header. And we also are using I down here in the statements. Now, you don't have to use I in the statements, okay? The statements are whatever you want to be run while the condition is true. But in this example, I am going to use I as a variable in our statements as well. So that's one of the reasons why it's usually a single letter. It's because we use it quite often. So before we get through the trace, I just want to remind you what's going to happen is we're going to run this initialization once, then we're going to check this condition. If the condition is true, we're going to run the statements. In this case, it's only a single statement. After the statement is run, then we're going to go back, update our I variable. Okay, so we go back, update I, and then we come back and we check our condition again. Okay, so now we just have pieces of code, whereas before I had words to kind of describe it. Now we have pieces of code in here. So what happens first is the initialization happens first. So I gets the value of 1. I is created, it gets the value of 1. Next, we check the condition. Is I less than or equal to 5? Right now it is, right? 1 is less than or equal to 5. So that means we're going to run our print statement. So that's a print statement. It says print I plus a space after it. So I is currently 1. We're going to print 1. And then all of our statements, there's only one of them, but the statements are done inside the for loop. So now we move to the update. And I plus plus means that I becomes 2 now. So I becomes 2. After the update is run, then my condition is checked again. So is 2 less than or equal to 5? That is true. And just like the while loop, while it's true, our statements are going to run. So this is true. I'm going to run the statement, which prints I, which is currently 2, plus a space after it. Okay. So you can see to the screen, of course I'm moving slowly, but all of these kind of appear at once on the screen because of this loop. I goes back up, it updates to 3. Is 3 less than or equal to 5? That's true. Run the statement. I updates to 4. Is 4 less than or equal to 5? Run the statement. Okay. I updates to 5. Is 5 less than or equal to 5? That's true. Run the statement. Okay. Update. I becomes 6. Is 6 less than or equal to 5? False. Okay. We've reached the false. Okay. At this moment. Now that I has become 6, 6 is not less than or equal to 5. That is a false statement. So the loop has ended. Okay? 6 never gets printed. The loop is never entered because that is a false statement, a false condition, and the code is completed now. Okay? So what gets printed to the screen here? 1, 2, 3, 4, 5. All right. Now, when you start getting good at these loops, we said the for loop at the beginning. I said the for loop is used when you know exactly how many times you want the loop to run. So when you start recognizing and getting used to the syntax, what you'll be able to see is, okay, I is starting at 1. I go up to and including 5. And I increases by 1 each time. So you would be able to say, yeah, this loop is going to run 5 times just by looking at the header. Okay. And it did. It ran 5 times. It printed 1, 2, 3, 4, 5. So the loop ran 5 times. So just from the header, you know how many times the loop is going to run. Okay. Whereas the while loop header, remember the while loop just had a single condition in there. We don't know how many times the while loop is going to run because we don't know, just looking at the header, what I starts at and how much I is going to go up. Of course, we could read the code and trace through and figure it out, but just in the header piece, we don't know how many times the while loop runs. Whereas in the for loop, we know how many times it's going to run. It's going to run 5 times in this case. Okay. All right, that's a lot. Let's try a different example just to kind of mix it up, a different look here. Now I have, again, the 3 parts. Now it's going to be a little different. It says I starts off as -5. Okay, so I is going to be -5. I'm going to check my condition. Is I less than 0? Okay, and it is. Okay, I is currently less than 0 because it's -5. So what I jumped ahead and did, I went ahead and printed off I, which is going to be -5. Okay, so I use the print statement. I come back up here and I'm going to update. And look at my update. My update says I equals I plus 2. So that's my new update for my I. -5 gets 2 added to it, and that becomes my new I. So it becomes -3. After the update, I go back and I check this condition. Is -3 less than 0? That's true. So I'm going to print off I, -3. I'm going to come back up here. I'm going to update. -3 plus 2 is -1. And then I'm going to check my condition. Is -1 less than 0? Or that is. Yeah, that is. So I'm going to print off -1. -1 gets 2 added to it and becomes 1. Okay. Then I check the condition again. Is 1 less than 0? That is not true. Okay. So because this becomes false, I am now done with the loop. Okay. So that's a mistake some students make, is once this becomes false, they think they go through one more time, from top to bottom is kind of the way their mind works. But once this becomes false after the update, then you don't do this one more time. As soon as it's false, you skip everything in the for loop block and you continue on with everything after the for loop. Okay? Do not run that in extra time. It's done once it becomes false. Okay? So -5, -3, -1 get printed to the screen. Okay? And again, you knew this was going to run 3 times just based on the for loop header, okay? Just based on the for, because it started at -5 and you can do the math. It's all there in the for loop to let you know how many times it's going to run, okay? What do the following code segments print? So we're going through, I think I have 2 more examples here, okay? If you want to pause it at any time to try it on your own, feel free. Okay, but we're going to start off with I being 100. 100 is greater than or equal to 95, so 100 gets printed off. I minus minus, so it loses 1. 99 is greater than or equal to 95. Prints, I loses 1. 98 is greater than or equal to 95. Print it off, lose 1. It's greater than 95. Print it off, lose 1. 96 greater than or equal to 95, print it off, lose 1. 95 greater than or equal to 95, print it off, lose 1. 94 is not greater than or equal to 95, so we're not going to print it off. Our loop, the condition has become false, and I am done with this code segment. Okay. So it gets repetitive. I like repeating that so you do kind of understand what the flow of control is, okay? This happens once, and then you're in this loop right here, okay? Then you're in that loop of condition, statements, update. Condition, statements, update. All right, our last example. I starts off at 1,000, okay? I starts off at 1,000, and we're going to go till I is greater than 0. As long as I is greater than 0, as long as I is greater than 0, we're going to go. Whew. But look at the update. The update is I gets divided by 20 and becomes the new I. So let's see what gets printed off and how many times this is going to run. Okay? Because even though I say you could figure out how many times the for loop runs just based on this header. But the math involved in this header, it's not like I expect you to be able to look and say, oh yeah, it's going to run, 6 times or anything like that. You would actually, in this situation, you might actually have to do the math and trace it out in order to know how many times it runs. But in theory, you see how you could look at the header and kind of figure it out, right? Okay, but the math is a little, when does it reach 0? Okay, because if you're dividing by 20, logically, okay, if I'm dividing a positive by a positive, it's always going to be positive. This loop is going to break when my integer division, when I get 0. Okay, so let's see when that happens. Starting off, I is for sure greater than 0. So I'm going to print off 1,000, and then I divide it by 20, which gives me 50. Okay, all right, look, I'm already down there. Okay, so 50 is greater than 0, print off 50. Then I take 50 divided by 20, that's 2, right? Because 20 goes into 50 twice evenly. 2 is greater than 0, so we're going to print off 2. And then I take 2 divided by 20. What's 2 divided by 20? Well, again, it's integer division. So you get 0, okay? Because 20 does not go into 2 at all. So you get 0. Is 0 greater than 0? No. Your loop ends. Okay? So it only ran 3 times. That's no big deal, right? No big deal. Only ran 3 times. We got 1,052. Ran 3 times, loop has ended, and that's what gets printed off. All right, that's your for loop. Okay, that's your for loop. Now, so you might see, basic tracing problems like that. Now we're going to look at just writing some simple for loops to accomplish a task. Right? So create a for loop that will calculate the factorial of the number 10. Okay? When you're writing a code to complete a task, if you haven't been doing this a while, which at this point you probably haven't, you might need to write out some pseudocode or at least some algorithm steps before you start coding. And not even to write them out, but at least think through what you want to happen. Now, before we get into what the steps are for writing this, let's make sure we all know what a factorial is, okay? Calculate the factorial of the number 10. Remember factorial? If I have 10, factorial is that exclamation mark. That we call that 10 factorial. And to calculate 10 factorial, what that means is we take the number we start with, 10, and then multiply it by 9, multiply by 8, and multiply it by 1 less every single time until we reach 1, okay? And then whatever that product is, that's 10 factorial, okay? It comes up at a few different spots in advanced math. So if you haven't seen it before, it's not like you've missed out on anything exciting, okay? So how do we calculate this? There's quite a few ways we could calculate this, both with a while loop and a for loop. There's actually 2 ways that I've seen students calculate a factorial with a for loop, and both are very valid ways. It just kind of depends on how your brain thinks. Let me just show you one example, okay? One would be to make the factorial variable because we need something to actually store the result in, right? Next, we want to make a for loop that starts at 1, goes up by 1 until we reach 10. So we had 10 factorial. I accidentally clicked off of my own page there. So we had 10 times 9 times 8 times 7 times 6. This is going to disappear every time I advance to a new slide, but that's okay. So for this algorithm, I'm actually going to start at 1, and I'm going to multiply by 2, multiply by 3, multiply by 4, 5, 6, and I'm going to keep multiplying until I reach 10. That's how my brain wanted to think. I wanted to think of starting low and going until high. What other students have done, and what is also very valid, is starting high, starting at 10, and going down by 1. You could do a loop either way. Again, it's just kind of however your brain thinks. I'm going to write code that starts at 1, goes up by 1 until I reach 10. And I'm going to be multiplying my factorial variable by that value I'm increasing by each time, okay? So what that's going to look like, I'm going to have a factorial. I want it to start off at 1 because if it started off as 0, anything times 0 is 0. You guys know this, right? So I gotta start it at 1, okay? And then the way I think is I'm going to have it start at 1 and go up to and including 10, increasing by 1 each time. So you see how step 2 here, when I put those into words, that was all taken care of in my for loop header. I starts off at 1, I increases by 1 up to and including 10. And what I'm going to do is I'm going to take factorial times I, and then that becomes my new factorial, okay, each time. So if I have 10, 9, I got to write this out every time. So fun. So if I start at 1, factorial is 1, and I starts off at 1. So 1 times 1 is 1. Perfect. Okay. And then I increases to 2. 2 times 1 is 2. Okay. So that becomes my factorial. And then I becomes 3. And then I take 3 times 2. 3 times 2 is 6. Okay. So factorial is 6. Then I becomes 4. So I take 6 times 4, which is 24. And then I becomes 5. 24 times 5. And then we're getting into where I'd have to do a little bit more mental math there. Excuse me, sorry. But yes, it works out and it goes up by 1. I increases by 1 each time, and factorial is multiplied by that every time. What you'll also notice here is that I did not include my curly braces. Just like with a while loop, with an if statement, the curly braces are optional if you only have one statement. Okay, so since this was only one statement in my for loop, the curly braces are optional technically, but you can also include them. Okay, it's up to you, just like we saw in our other examples. Okay. All right, let's try another task. Write code that will print off all odd numbers from 50 to 100. Okay. If you want to try this on your own, pause the video and start it back up when you're ready to see what I coded as the solution. But if you're struggling, here's a good place to start. Whether you write out these steps off to the side or at least think about them. When we're writing code to accomplish a task, we want to think in terms of algorithmic steps, right? So start at 50, go up by 1 until 100, right? So those 3 things, right? Starting point, how much I go up by, and then when do I stop? All of those tell me I can use a for loop for that, okay? Because those 3 things are taken care of in my for loop header. Start at 50, go up by 1 until 100. Then I ask a question, is it odd? Okay, is it odd? And print it off if it is. Now, these are the 3 steps that I came up with, okay? Did you come up with some other steps? Because there's other ways to code this solution as well. Okay, I'll talk about them after I show you the code for this, okay? There's other ways to code this, though, that are also clever, but this is how I thought, right? Okay, if I'm going from 50 to 100, let me start at 50, and I'll go up to 100, and I'll just increase by 1 each time. I'll check every number. If that number is odd, so I'm going to ask a question. Is it odd? So I take X, I mod by 2, and if it's equal to 1, then I know it's odd, and I want to print it off. Okay? Now there's a different way to do this as well. Okay? There's a different way. So this is how my brain thought. 50 to 100, up by 1, ask if it's odd. If it is, print it off. And it works. This accomplishes the task perfectly. But there's another way to do it as well. What if you know 50 is even, right? When you're coding, like, yeah, 50 is an even number. Awesome. So let me just start at 51. Go up by 2, end at 99, and then just print off all of those numbers, right? And I just print off the value. This also works and accomplishes the task in the same way. It just does it. I say accomplishes it in the same way. It does the same thing. It prints the same numbers, but it does it in a totally different way. Now, because you're starting at 51, going up to 99, and you're going up by 2, you're printing off 51, 53, 55, and you're going to print off all the odd numbers between 50 to 100. Okay? Both are very valid. You can use both. It's a good demonstration of when you're writing code, you have to go with how your brain thinks. Some of you might have thought about it this way. Some of you might have thought about it the first way, where you ask a question. You go up by 1 and you ask each number a question. Is that number odd? Okay. Whichever way you want to do it, that is going to be completely acceptable in your code, okay? Recognize both ways, right? So if I gave you this code, you'd look at this and say, oh yeah, okay, I didn't think about it this way, but I know why it prints off all the odd numbers, okay? That's fine. At least recognize it, but just go with how your brain thinks, all right? That's the beauty of code. You go with how your brain thinks. Okay, let's talk about a type of error that can occur when you are working with for loops. It's called an out of bounds error. We'll be talking about this more in the next lesson as well when we work with string algorithms and for loops. But this is going to be our first code segment that deals with for loops and strings. So the code I'm about to show you attempts to print each letter in the word str on a different line. Why does the following segment of code produce an error? Okay, so let me show you how we use a for loop to go through a string. Okay, so the string str, I just put howdy. Okay, so what's going to happen is our initialization, I is 0. And then look here, our condition is I less than or equal to str.length. Okay, less than or equal to str.length. So that's going to be the way we code in, saying we are going to go through the length of the string, okay, the string howdy. Now, how long is howdy right now? Howdy is 5 characters, right? So the str.length is going to be a 5. Okay. That's a 5 right now. And that doesn't change because the string isn't being updated at all. It is a 5. So I less than or equal to 5, and I is going to go up by 1 each time. So what am I going to do? Well, I'm going to print off on each line str.substring I, comma I plus 1. Okay. So when I is 0, okay, the first time through I go from 0 to 0 plus 1, which is 1. Okay. So what is the substring 0, comma 1? That's just the H, right? So H gets printed. I increases by 1, so I becomes 1. And then the next time through, because I is still less than length, I go str.substring 1, comma 2. Okay. What's str.substring 1, comma 2? That's going to be, I almost said 0. That's going to be O, the letter O, Goldie. Okay, the letter O, 1, comma 2. I increases to 2. 2 is less than str.length. So then we got 2, comma 3. Next, we got 3, comma 4. Then we got 4, comma 5. And then I becomes 5. 5 is less than or equal to 5, so my loop runs. And I got 5, comma 6. But what is the substring of 5, comma 6? Okay. This is where an error occurs, right? Because what are you trying to do within this right here? 6 is not a valid index, okay? Technically, 5 isn't an index, right? 0, 1, 2, 3, 4. But here, there's no error because of the way substring works. It goes up to 5, but not including 5. And because there's no 5 and it doesn't include 5, this code right here, 4, comma 5, does work. It'll print off the Y. But when you try to access 5, comma 6, all of a sudden you're trying to access index out of bounds, okay? An index that's out of the boundaries of the str. So you're going to get an error when I is 5 because I cannot be 6. We saw when I could be 5 inside the substring here because of the way the substring method works, and that's okay. You don't get an error there. But you do get an error when I is 5 because it's trying to access that 5th or that 6th index when you can't. Okay, so you get an error. All right, so we're going to edit the code to fix the boundary error, and it's a very simple edit. And I bring this edit up now because this is something you're going to be running into both with strings as we're working with strings, and you're going to run into this error a lot in Unit 4 when we start working with arrays and array lists and all of those good things. You are going to run into boundary errors. It's just natural when you're starting to learn new stuff. These boundary errors are very common, and there's a simple fix for them. What's the fix? Changing this from less than or equal to just less than. Okay. All of a sudden, you could do 4, comma 5, but the second I increased and become 5 is not less than 5. So that condition becomes false and the for loop is exited. Okay. And then you don't reach that boundary error that we just had an issue with. Okay. So boundary errors usually happen at either the beginning or the end of the way you have your for loop structured. And we're going to run into a lot of those examples in the next lesson. Okay. But I wanted to introduce it to you now, let you know. But as we start working with strings a little bit more, it's going to be something you want to keep an eye out for. If you have a boundary error, you're trying to access indexes that don't exist, and the simple fix is just to change your condition. Okay? Sometimes we change this part, like here, the simple fix was just changing this from less than or equal to less than. Other times, the fix is going to be taking str.length and just subtracting 1 from that. Okay? And we're going to see that fix in the next lesson. In this lesson, the last thing I want to finish off with is a comparison of while loops versus for loops. They can be used interchangeably in almost every single situation. They can be used interchangeably for every situation when you know the number of iterations before a loop is run. Okay? If you don't know how many times a loop is supposed to run, you are going to have to run a while loop. Okay? But a for loop, technically, don't come after me, but technically you don't ever have to know a for loop, right? Because anything you use a for loop for, you are able to write a while loop for, okay? We like the for loop though, again, because it has everything in that header, you can look at that and just know how many times that's going to run and also what it does. You know, if it's going through a string or going through an array, it's a very good way of communicating that as well. But you do have to know it for the AP exam. So here it is. Okay. So let's say I have this while loop. What I just did, right, where I wanted to print off the letter on each line of a word, STR. Now for STR, if it's howdy, I know the word. Let's say I don't know what STR is going to be. I don't know what word it is. It could be a word of three characters. It could be a word of 100 characters, right? I don't know. But I do know, okay? I don't know exactly what word's stored in there, but I do know how to access the length of that word. So I do have an ending point for it. So here's what that's going to look like as a while loop. I start off as I equals 0. My while loop just has the condition. I have the statement where I print off the one character, and then I have my update. So you see all of the pieces for the for loop here. You have your initialization, you have your condition, and you have your update. Okay? The for loop just takes those 3 things and puts it into one header, okay? While the while loop spreads it out. Okay? So here's what that looks like, what we just did. Again, the correct way without the boundary error. This is what it looks like as the for loop. You take your initialization, condition, and your update, and you put them into one header. Okay? So that's why any loop that we write as a for loop, we can also write as a while loop. Okay? The vice versa isn't always true. Anything you write for can be written as a while loop, but not every while loop can be written as a for loop. Okay? Not every while loop can translate good into a for loop. So let's say you have this. I want you to take a moment. I want you to write this code as a for loop. Okay? Pause the video. Write this code as a for loop. Okay? And hopefully you paused it, tried it, started it again. Here we go. What does this look like? Okay? Here's your condition, your initialization, I should say. You start. Here's your condition where you put it right here. And then this is the update that you are going to want to put right there. Okay. Now notice how, okay, so it's very cut and paste as it's written right now. Okay. Because any for loop is also going to be good as a while loop. So you see, if I gave you this, which I do something similar in the next example here, you can easily translate that into a while loop. But that's not always the case with a while loop. Like, let's say, what happens if I put this update right before here? You know, that's going to change how the while loop functions a little bit, and you won't be able to easily write a for loop. You could still do it. You would have to do a little bit of thinking, but you could still do it. Or if you had something like in here where the user was, let's say, inputting a value or changing the value in some way, it's not as easy to write a for loop for a situation like that, okay? But for something like this, if you're given a for loop, you can easily take that and put it in a while loop. Going from a while loop to a for loop, you kind of need it to look like this. You kind of need it to almost be a carbon copy, put it in the for loop without having to do any more extra thought to it. You can always go from a for to a while though. Okay? If you want to try that, pause it, try it. Let's see what you got. Okay? Here's the answer. Okay, this initialization, excuse me, I keep saying condition. This initialization has to go before the while loop. The condition goes inside the while loop condition. And the update of a for loop has to be the very last line in the while loop in order for those two loops to be the same. Because that was the goal here with these two code segments, is writing two code segments, one with a for, one with a while, that do the exact same thing. If you put that update condition before, let's say, the sum, you are going to be changing the sum differently than if you put it after. Okay, so you'll want to be careful of that. All right. But that brings us to the end of our notes here. We have introduced the for loop, the syntax that goes along with it, the flow of control, all of that good stuff. In our next lesson, lesson 7, it's all going to be about string algorithms. So we're going to be using for loops and seeing how we can apply them to work with strings specifically. Okay, so thank you guys for sticking along. If you have liked this video, please hit the like button and subscribe to my YouTube channel for more great AP CSA content. And until then, I will see you in the next video.